Good afternoon, everyone. Sorry I'm not back today. The surgery was a little bit more involved than they had thought it was going to be, which as a result, I'm a little bit more in pain than I anticipated, but I will be back tomorrow, though I just needed one more day. So I don't have your test graded because I have the wrong answer key at home. I have the answer key for the other version, so I will pick that up tomorrow, obviously, and then get those graded for you guys. So on Friday, you guys learned SOHCAHTOA, and we're going to use SOHCAHTOA to help us solve for right triangles today. And to solve for triangles means to find all the missing sides and angles. So a triangle has 3 sides and 3 angles. So to solve means to know all of that information. Okay, and we can use Pythagorean theorem and SOHCAHTOA to solve. Okay, so for the first example, hopefully you know that across from this is the hypotenuse, and we recognize that this is actually a Pythagorean triple. Remember that the hypotenuse always needs to be the longest side, and so BC equals 8. Okay, so that's one piece of information. So we're missing 2 of the angles, okay, and when we go through this, we're going to use SOHCAHTOA. Now, it doesn't matter which angle you start with. So I'm just going to start with angle A, and then always use the information that's given to you. So just in case you made a mistake. So let's say you said BC was 10 for some reason. If you use that side, then that angle is going to be wrong too. Okay, so a good active note is always use the information that was given to you to find missing parts, not the information that you found when using SOHCAHTOA. Okay, so if working with angle A, 15 is going to be adjacent, and then 17 is going to be the hypotenuse. So which trig ratio uses adjacent over hypotenuse? Hopefully you said cosine. So cosine A equals 15 over 17. Okay. Now, remember from Friday that anytime you are solving for an angle, remember that you need to do the inverse operation in your calculator. So A equals the inverse cosine of 15 over 17. Okay. And then the directions say to round to the nearest degree for the angles. So this, when you plug this into your calculator, first of all, make sure that your calculator is in degrees. So go to mode and make sure degrees are highlighted. Sometimes if you use a program in your calculator, it'll change it to radians. So just before you guys start, always make sure that your calculator is in degrees, especially if you're borrowing a calculator from us. Okay, so inverse cosine of 15 over 17, and that gets you 28 degrees. Okay, now since we're working with right triangles only, this angle right here is 90 degrees. So that means that A and C have to add up to 90 degrees. So to find the second angle, okay, all I have to do is take 90 minus 28, and I get 62 degrees. Okay. So we have all the information now for the right triangle. Okay, A is 28 degrees, C is 62 degrees. Remember that a triangle has to add up to 180, and then BC is 8. Now I could have done this problem a little bit differently. I could have started with angle C. If I would have started with angle C, this side would have been opposite, and this side still would have been the hypotenuse. So I would have done sine this time of C equals 15 over 17. Okay, and you go through it and you still get the same answer. So it doesn't matter which angle you start with first. Okay, just make sure that your ratio is correct for that angle. All right, let's move on to the next one. Okay, so looking at this one, we have one side and 2 angles. So when you have 2 angles, finding the missing angle is going to be the first step, because that's going to be the fastest step. So angle A is 90 minus 34, which gives me 56 degrees. Okay. Now we're going to, when we go to find the sides, we're going to make sure that we use the given information just in case we made a mistake finding that other angle. So I'm going to work with angle C. Okay. It doesn't matter which side you find first. I'm just going to go ahead and find the side that's adjacent. So this is adjacent and hypotenuse. So the ratio for that would be cosine. So cosine of C, cosine of 34 degrees equals x over 21. Okay, and then just like Friday, we're going to multiply both sides by 21. So x equals 21 cosine of 34 degrees. Okay, plug that into your calculator, and we should get approximately 17.4. Okay, for these sides, it says round to the nearest tenth. So 17.4 equals BC. Okay, so the last thing we need to do is we need to find the missing side. Now I could use a trig ratio again, and I could do, if I wanted to, sine of 34 equals, we'll label that y over 21, and do the same thing. Or I can use the Pythagorean theorem. Okay, so it doesn't matter which one you choose when you have an angle besides the right angle. So let's just do, this finding the angles. So y equals 21 sine of 34. Okay, plug that into your calculators. Plug that into your calculators, and you should get approximately 11.8. Okay, and that equals AB. Okay. So like I said before, we also could use the Pythagorean theorem though to solve this, to find the missing side. And what you guys would have done was AB squared plus 17.4 squared equals 21 squared. Okay, and you would go through and you should get approximately the same answer. It might be a little bit different depending on the rounding. Okay, so I actually found, when I keyed this, I found the 11.8 finding this way. So if we did this and it was a little bit different than 11.8, that's why. Okay, next example. Notice that we were given two sides here. So the first thing we have to do is find, well, it's not the first thing we have to do, but the first thing I would start off doing is find the missing side. Okay, and this is going to be the hypotenuse. So 6 squared plus 12 squared equals AC squared. So we get 36 plus 144. So that's 180 equals A squared. And then when you take the square root of 180, you get approximately 13.4. Okay. All right, now we need to find one of the missing angles. Okay, remember that always use the given information, so we're not going to use that 13.4, especially because the 13.4 is rounded, so it's not going to give you an exact answer. It doesn't matter which angle you start with, if you start with A or C. I'm just going to start with A. So this is opposite, and this is adjacent for A. Okay, which trig ratio is that? Hopefully you said tangent. So tangent of A equals 12 over 6. Remember that anytime you're finding an angle, you need to use the inverse operation. So A equals the inverse tangent of 2, which is approximately 63 degrees. And then to find the other angle, we'll just do 90 minus 63. So that's 27 degrees for C. Okay. If you would have started with angle C, then you still would have used tangent, but this time it would have been 6 over 12. Okay. So it doesn't matter which one you start with. This matters if you have the ratio correct. All right. Moving on. We're going to now talk about special right triangles. Hopefully you remember these from geometry. Okay, so we're first going to start off with a 45, 45, 90. So this is the general rule. Okay, the legs are the same, and then the hypotenuse is the leg multiplied by root 2. Okay. And then a nice little organizational chart for this is setting it up like the following. Okay. Now, do you have to use the organizational chart? No. I just think it helps some of us remember the rules. Okay. So this is for a 45, 45, 90. Okay. When solving special right triangles, you're going to do this without a calculator. So at absolutely no time should there be decimals when working with special right triangles. Okay, so notice that the angles here are 45 degrees and 45. So we have a special right triangle. So I'm going to go ahead and set up that organizational chart. Okay, and actually let's go back up top. There's one more little rule I want to add on to this chart. When you're going to the right from a leg to the hypotenuse, you multiply. And then when you're going from the hypotenuse to a leg, you divide. Okay. So going to the right, we multiply. Going to the left, we divide. Okay. All right, so remember that the hypotenuse is always across from the right angle. So in this example, they gave us a leg. So this is going to be 14. And then we also know that the same leg is going to be 14, and since we're going to the right, that means we multiply, so 14 root 2. So we have x equals 14 root 2, and y equals 14. Okay. All right, so let's go to the next example. So this is a 45, 45, 90, so I'm going to set up that chart. And then fill in the information that was given to us. So across from this is the hypotenuse, so I get 32. And remember that when you're going from from a hypotenuse to a leg, we're going to divide by root 2. So take 32 and divide it by root 2. Okay, we don't want to leave a radical in the denominator, so we're going to rationalize. So 32 root 2 over 2 simplifies to 16 root 2. And since the legs are the same in a 45, 45, 90, then both legs will be 16 root 2. So x equals 16 root 2 and y equals 16 root 2. Okay, one way you can check your work to make sure that you did this correctly is take 16 root 2 and multiply it by root 2 to see if you get 32. Okay, in this case we would, so we did it correctly. All right, let's move on to the next page of the notes. And this one is for a 30, 60, 90. Okay, really important here is that everything is based off the short leg. So when we do this organizational chart, it's always about based off the short leg. How do we know which one's the short leg? It's across or opposite from the 30-degree angle. So our short leg is going to be A, so that's across from 30 degrees. The long leg is A root 3, that's across from 60 degrees. And then the hypotenuse is 2A. Okay. So you can't go from the long leg to the hypotenuse, so you always need the short leg. Okay. And then once again, we're going to use an organizational chart. So this is going to be A root 3, and then 2A. So from the short leg on, we multiply. Okay. And then either one of these, if we have to go backwards, we divide. Okay, so to the right is multiplying, to the left is dividing. Okay, and big thing here is everything is based off the short leg. Okay, so looking at the first example, okay, so we're going to set up that little chart. Okay, and then we're going to look at the information. First of all, this is going to be a special right triangle, so 30, 60, 90. Okay, and the side that we have is actually across from the 30-degree angle, so that's nice for us. That's just going to be 11. Okay, and so then we're going to the right, we're going to multiply. So this is going to be 11 root 3, and then 11 times 2 is 22. So x equals 22 and y equals 11 root 3. Okay. So when you have the 90-degree angle, when you have the 30-degree angle, that's always the nicest one because then you can just go ahead and multiply and get your information. Okay, next example. This is a 30, 60, 90 once again. So we're going to set up our chart. Okay. Notice that this time the information that we have is the long leg. Okay, it's across from the 60-degree angle. So everything is based off the short leg. So if I have the long leg or the hypotenuse, I have to go to the short leg first. And when we go this direction, we divide. So I'm going to take 9 and divide it by root 3. Rationalize it. So that's 9 root 3 over 3, which is, oops, sorry, I was thinking of the hypotenuse already, which is 3 root 3. Okay. And now that I have the short leg, I can go ahead and multiply to the hypotenuse. So 3 root 3 times 2. Remember that you multiply outsides together and insides together. So since that 2 is on the outside, it doesn't have a radical, then the answer is just 6 root 3. So x equals 6 root 3 and y equals 3 root 3. Okay. All right, and we have one more example. Okay, notice that all these examples show you each different way. So when you're doing your homework, if you get stuck, look back to your notes. The first example, we were given the short leg. Second example, we were given the long leg. And third example, we were given the hypotenuse. Okay, so everything has to go back to the short leg. So hypotenuse to the short leg is just 24 divided by 2, which is 12. And then short leg to the long leg, we multiply by root 3. So x equals 12 root 3 and y equals 12. And you notice that y is across from a 30-degree angle, which is the short leg. So like I said, if you get stuck, all of your notes have each example that you might see. So get your notes out and take a look. Okay, as always, you guys, please help each other out, especially since I'm not here. And then I will be back tomorrow. Okay, I hope you guys have a wonderful day, and thanks for hanging in there. See ya.